Hello, class. I wanted to do this tutorial to help you navigate through the virtual laboratory for at least the week one lab experiment. And so let me start by showing you. So this is the Moodle home screen. You have the virtual lab tutorial. You do need to go through this tutorial in order to be able to have access to the virtual lab itself. This is just an extra tutorial that I'm doing to help you navigate through a few things that I want to highlight for this first week's lab, and it does apply to all the future labs that you'll use virtual laboratory for. Other things I do want to point out is the laboratory report instructions. Very important that you go through this. This helps you to understand what you need to do to type up your laboratory report. Very important. For doing the lab report, this is just a guide to show you what the instructions are. It is not made to be used as a template to fill in information. You are going to have to create your own document for your lab reports. This also is the lab report grading rubric to help you know how your lab report will be graded. So for week one, and you'll have access to this once you have completed the participation and academic honesty verification. You will have access to your week one documents. But for week one, you have the Turnitin. This is where you will upload your lab report. The week one laboratory procedure, this is where you'll get the information to know what to do for this particular week's lab report. So we're going to go back up to the virtual laboratory. So once you've done the lab tutorial, you'll be able to access the virtual lab. It opens up in a separate window. This is so that you will have plenty of room to navigate through your workbench. And so up here at the file, you're going to click on this. You're going to load the assignment. And for this week's assignment, we are working with molarity and density. And you'll see that when you click on the lab instructions. And it tells you to go down to the metals density problem. So you're going to click on that. And you see all of this information that's in your stock room. So you have distilled water, you have your three metals, because we're working with three metal unknowns that we're going to identify for this particular lab. You have your glassware, your Erlenmeyer flask, and the different volumes for that. You have your graduated cylinders, you have your different volumes for those as well. Then you have your pipettes, your different volumes, and your disposable pipette. You have your beakers, your different volumes for your beakers. And then you have your volumetric flask and those different volumes. And then you have the others. You have your foam cup, your weighing boat, and your burette. Then for tools, you have a Bunsen burner and your scale balance. So for this first part of the lab for the procedures, I'm just going to walk you through one of your trials just so that you know how to set this up. So you're going to need your water. You're going to need metal one, right? And see how you can click and drag and move it to different areas of your workbench. For your glassware for this first part, you're going to need a 10 milliliter graduated cylinder. You're also going to need a 250 milliliter beaker. And you see how it just kind of adds it in one corner, but you can click and drag it to wherever you want to place it on your workbench. You're also going to need a scale balance. So I'm going to move that out of the way. And you are going to need under glassware, you're going to need this weighing boat. Okay. All right. So, and I'm going to just go through the first part and we'll look at the instructions. And this is going to be on the Moodle homepage, so you can follow along at any time. On your scale balance, there's this tare button. That tare button you're going to click on anytime you want to zero out the balance, okay? And so it's going to tell you that in the instructions. So we're going to take the weighing boat, place it on the balance, and you see how I dragged it until you see the dotted line on the scale balance? That way you know that it's listed there, all right? And so the weighing balance, the weighing boat, it measures 4.7046. And anytime you are working with measurements for the balance, all of those numbers are significant. We talk about significant numbers in your measurements, and you'll talk about that in this week one. But all of those numbers will be significant. And so it's important that you do write down all the numbers. Once you've done that, you're going to tare that again. All right. When you're taking measurements for the lab, always have a notebook or a piece of paper or something handy so that you can write down all your volumes as well as mass measurements. Those you're going to include in a table when you type up your lab report. All right, so now you're going to take Metal 1. Anytime you want to add something to it, you're going to click so that you see that dotted line and you see that you can add a measurement. For this, there's two ways that you can add it. So you can do a realistic adding where you just pour it directly onto the balance, and then it's going to give you a measurement. We want our mass to be within 3 to 15 grams. And so you see that it gives you a mass that's within that. And so you can go with that mass measurement, but you do want to write that down. So we have 5.6752 grams. And so you're going to write that number down. Once you've done that, you can set that aside. You can tare your balance, and then you can move that out of your way. Okay, we're finished with Metal 1 for right now, so we can move that out of the way. The next thing we want to do is we want to add 250 milliliters of water to our beaker. And so we're going to move it to the water is over the beaker, and we want to see that dotted line. And so we want to add a precise volume. And so we're going to add 250 milliliters, and then we're going to pour it. Okay, so that's the other way we can add a particular amount to our apparatus. And so now we want to pour from our 250 milliliter beaker to our 10 milliliter graduated cylinder. And we want to pour, you can do realistic and just hold and pour. That time it gave you 4.33 milliliters. And according to our instructions, we want it between 2 to 7 milliliters. So that's perfect. So we're going to write down 4.33 milliliters. Another way that you can read the volume is directly. And so when we're reading the volumes, we want to, if we close this out, you see how the graduated cylinder is just sitting there with the liquid. You can right click on it and click on detail view, and then it'll bring it right back up. And so we have 4 point, each of these markings in between the 4 and the 5 or any of the numbers is 0.2. And so we have that the bottom of the meniscus or the bottom of that smiley face is between 2 and 4. And so you could kind of guess, okay, so it's a little more than, it's about halfway between the 2 and the 4. So you could say it was 4.30, okay? The 4.3 would be known. That last zero is an unknown, kind of a guess. We saw when we poured it in that it told us it was 4.33, but say we forgot to write that down. So you would say maybe 4.30. Because that last digit could vary depending on who's making the measurement, we call that the uncertain digit, but it still is an important part of our measurement. And so we still want to write that. So we have 4.33 milliliters based on that. Or you could have written 4.30 if you didn't have that. So now the next thing we want to do is add our solid to our graduated cylinder. And so we're going to take our solid, go over to the graduated cylinder. When we see that dotted line, then we release it. We know the precise amount that we have. So we know that we have 5.6752. That's our grams, and we want to pour it in there. Okay. And so now it's been transferred. So once it's transferred, we see that our volume increased. So we want to write down what our new volume is. And so our new volume, all right, and so it looks like it's above the 4.8, but not quite at 5. So say we are going to say it's 4.83. Okay. So say we do a volume of 4.83. So that's the volume that it increased to once we added the solid. So now to find out the volume of the solid we added, we're going to take the 4.83 and we're going to subtract 4.33. And when we get that, do that, we have a volume of 0.50 milliliters. That is the volume of our solid. So to determine the density of our solid, density is mass divided by volume. Okay. And so mass divided by volume, for our mass, remember we measured a mass of 5.6752 grams and our volume 0.50 milliliters once we have done our displacement. So what I want to do is I want to stop sharing this screen and share a whiteboard so you can see the calculation. All right, so now we're going to write on that. So our density, ooh, that's too fat. All right, let's see if we can erase this. All right, so let's erase that. Let's go back to the pen. Okay, that was a little too big. Okay, so there we go. So we have our density, D for density, is equal to mass divided by our volume. Okay, so you can see that's mass over volume. All right, so our mass, remember, was 5.6752 grams. And remember, our volume, we had to subtract those two volumes. And so I just want to show you here on the side. So we had 4.83 milliliters once we poured our metal one into our graduated cylinder. And then we're going to subtract the 4.33 that we had of just the water by itself before we added metal one. And that was milliliters. When we subtract that, we get 0.50, and that was milliliters. Okay, this is known as doing the volume by displacement. And so once we have our displaced volume, so that's our volume of metal one, milliliters. All right, so when we do the math for that, so we're going to take 5.6752 and we divide it by 0.5. All right, so we get a density of 11.35, and the units are grams slash milliliters. Right. And when you're looking at this, when we're doing significant figures for our calculations, for division, you will learn in this week, you will always go with the least number of significant figures. So 0.50, it should have been 0.50 has two significant figures, so your answer should have two significant figures. But for this lab, because we are doing 3 trials, I suggest that you don't do your final rounding to the very end, okay? So you want to keep, I would say, a couple of decimal places for your densities. And then when you do the average density for your 3 trials that you're going to do, then you can do your rounding at the very end. All right. And so if you have questions, remember, I just went through the first trial for the first metal. And if you have questions as you're navigating through this lab and doing the calculations, please let me know. Anytime you do calculations or you have different values, remember all your values you want to put into a table to place into your lab report. And all your calculations, you do want to include your calculations in your lab report as well. If you have questions though, let me know.